That roof is on fire. Oh, we gonna take it high.
In classes. Okay. So classes, right? So does anyone have an idea what a class is? Anyone at all? Because I think you had began with the okay. There's gonna be. Should I tell you now or after? I think I'll tell you at the end of the class. Okay. Um, so yeah. So we're gonna start with what is a class, right? So if you remember, we were working with structures not so long ago. And if you don't know what a structure is or you don't remember, I'll send or yeah, if someone wants a video on the structures, the videos are still there from last semester. So if you don't have access to the old videos, please do let me know and then I can give you access to those videos so you can look over some things and try and understand better or like just have knowledge about them, right? So class class and object basics basically. So what is a class, right? So I wanted to start off with the structure, right? We were using a structure where we had um, other data types inside our structure, right? So our structure was able to, let me see if I can open it here. Um, yeah. So here was an example of our structure, right? Our structure was able to hold this 2D array variable that we made. It was able to hold integers. You could even make it hold strings, or you could even create another structure and store another structure in a structure, right? So following that, we are going to be working similarly that way with classes. But with classes, it's going to be a lot more cleaner and a lot more better and efficient and even convenient, right? Because the class is going to, so the class is an abstract data type, right? It is a data type which you create, right? So just like the structures where in computer science, right, there's already like integers, there's already strings, there's already variables that exist, right? So think of a class as you creating your own variable, right? But this variable isn't just data, right? This variable also stores functions that work on that data, right? So you could have an example. If I can just open this. So let's say you have this structure that has rows, right? And then maybe let's say the rows are. Uh, can you guys excuse me for a moment? Just a moment. Sorry about that. Okay. So like I was saying. So for example, let's say there's a structure, right? Let's say there's a structure, right? And then you have rows here. And then maybe in your program, someone does something which these rows here must be subtracted or deleted or something, right? So you must, in a class, what we can do this in a structure as well, but we'll just be doing it in a class, right? You can declare a function which works with these data or this data here. So this function can manipulate your data, right? So our class will have functions and also data types, right? So what is a function? Before we get to all that technical stuff, think of it as a blueprint, right? Like a plan for something, right? In this case, I'm using a house, right? A class is a blueprint or a template for creating objects, right? So objects or instances are like the actual class in itself, right? When you create a class, it will be called an instance, or yeah, when you create a class, it will be an instance of the class. But then you'll have this template, right? So when you think of it logically, you only have one plan, but then you can have many like buildings, right? So in this case, you see this neighborhood is like, yeah, those American neighborhoods where all the houses are the same, right? The plan is the same, so the class is the same, and then there are multiple different instances, right? And then there is a possibility that with the same plan, the first house might be blue, the second house might be red, this third house might be yellow, right? But then it's still the same house, but then it has slightly different values or different data, right? So there is a class and then there's an object, right? A class is the blueprint, so the plan, and then an object is an instance of the class. So an instance is like when you create it, right? So we'll see now we're gonna have constructors and destructors, right? So you will use the plan or the class to create an object, and you can use that object, right? So yeah, the class is like a blueprint of a house, and then object is the actual house built from that blueprint, right? Any questions before I move to the next slide? Any questions at all? You can even type them in the chat. No questions. Okay. So does that mean everyone is understanding so far? What's a class? Thumbs up if you understanding. And if you put a thumbs down, like be ready to. Okay, okay, okay. That's good. So that is a class. It's a blueprint to an object, right? So a class comes with two main things, right? You have the members of the class, right? So the members of the class is what the class stores essentially, and they could be variables and functions, or rather they are variables and functions. So I don't think we'll ever create a function or a class, sorry. I don't think we'll ever create a class where there's only variables or there's only functions. There's always going to be both, right? And then a class member can be data members, so variables, or they could be function members, which is your functions or your methods, right? And then you'll see later that some of these functions or most of these functions are going to be functions that manipulate this data, right? So let's say we have, I'll start with the easy ones. There's two. I'm not sure if I have. Okay. So I'll start with the simple ones, right? Um, or should I explain it after this? Okay, I'll explain it after that. But so in your class, you have variables and your functions, right? So your functions are actual methods, right? These are your functions. These are your functions. So let's pretend this is a class, right? This is our, so these are functions, right? So this will be a function. This will be your functions here. So deallocation, allocation, those would be functions. And then you'd have your variables, which in this case is our game state, right? Because it has like variables or data, right? It stores data. So like, yeah, here will be our variables, right? So yeah, here's another analogy to make it like easy or something you can relate to. You can think of a class as a toolbox, right? The variables are the actual tools that are inside the toolbox. So the data, the tools, and then the functions are the instructions on how to use these tools, right? So functions are like sort of the manual, right? Or uh, or steps or like a recipe on how to do something. That's the purpose of your functions, right? Uh, so good, so far so good. Thumbs up, thumbs down. Are we still together? Okay. Yes, there's a question. Um, yeah, Amatle, yes, I saw your hand. Or was it in the chat? Let me check. There's nothing in the chat. So. Okay, you're good. Okay. Okay, yeah. So that is what you can find inside your class. You can find your data variables or your functions. Right. I'll move to the next slide. Now, in your functions, so I'm gonna be using this a lot. There's gonna be when you're coding, right? You're coding your program, or if you're coding your program for a user, right? So majority of the time, the user is also called the client, right? So this client or this user is the person who's gonna be using your program, right? So let's say we have created this class. We're gonna have a user or a client, same thing, who is using your class, right? So you're creating the class for them, right? So when we are coding, generally you'll see that the user of our, let's say here we created a module, right? We created this module called simulation world. Who can tell me who the user for this was? It's not the end user, it's not the person, or who's the client rather. Let me say it that way. Does anyone have an idea? You can even try. Okay.
Can you repeat the question?
Who was the client of the class of the module, or who was the user of the module? It can be a person, it can be another program, it can be another class, but something or someone that was using our module. Who was the client? Okay, there's no wrong answers. Well, there are some wrong answers, but there's no wrong answers in my class.
Me?
Say that again.
Me?
You.
Yeah.
Okay, that is correct to a certain. So that, yeah, that is correct. Okay, yeah. So there's a answer in the chat here. Main. So that was the answer I was looking for. But yours is also correct, right? So you are the user of the class two, but main is the direct user. Like the main class is the one that is interacting with your module, right? So if you think of it in a sense of when we are creating applications, right? The end user, or you, right? This person does not code anything, right? Or you don't when you're using an application, you won't say, let me see if I can, you won't call initialize, right? You'd probably click a button on a GUI, a GUI, which is a graphical user interface, right? Unless you are using the application using the CMD, then you can say it's you, right? But a lot of the time there's gonna be, you see like this GUI here, right? This is probably what you'll see in maybe next year if you're gonna continue computer science. You're gonna start creating, but I think you also do this in informatics. If you're doing informatics, you create graphical user interfaces, right? So the person usually interacts with the graphical user interface, and then that is controlled usually by main, right? And then main is the one that is talking to the module. So in this case, in our case right now, it will be different for different scenarios, but in this case, main is the client, right, of our module or our class, right? So with that in mind, right, main is using the client, right? Main is using the class, sorry. So when we create the class, right, think of main as another programmer, right? Someone, you coded this thing and you're giving it to your classmates to use in their practicals. You're giving them a class to use with some functions that will be helpful, right? You don't want them to steal your ideas, right? So you want to hide some of the things, right? That's where these access specifiers come in, right? Or they can even be used for protecting the integrity of your class, right? Because you don't just want to give anyone access to the data. Think of a bank, right? Uh, the money is yours in the bank, but then when you go and deposit or withdraw, you speak to like an interface, you speak to someone who then gets the money for you, right? They don't give you access to the vault or the safes and then they just say, yeah, you can take money or you can put money. You have to speak to someone who knows how to properly interact with that, with the money, right? So similarly, our classes work the same, right? We have this private, which is only accessible inside the class. So everything that's going to have the private keyword, main won't have access to it. It can have access to it indirectly, which we'll see now, but directly in main you cannot call private members, so you cannot call private functions and all private variables, right? And then we'll have public, which now public is the one that you're giving access to. Everyone can access the public members, right? So the public functions, usually we don't have public variables, but if they were there, then those variables you can access using, or they can be accessed outside the class by the client, right? And then we have protected as well. Now protected is accessible in the class, so it's like it's almost like private, so it's in between private and public, right? I should have put it in between here, but yeah. So protected is in the class, and also it gives access to derived classes. So later on we're going to do inheritance, um inheritance, association, um yeah, object orientation, right? And then you will see how this will be implemented, right? But for now, you just know that private is only accessible inside the class. So things you want to keep private inside the class. Public, anyone can access them, any client can access them. So if you're creating an app for other programmers, know that when you create something private, they don't have access to it. They only have access to public members, right? And then another analogy here, um, you can think of it as a house, right? The private part or the private members are like your bedroom. Usually, like only you go to the bedroom. If you have guests over, they barely go to the bedrooms, right? And then public is the living room, so everyone has access to this room, or rather, even this room is designed to host or for guests, right? For the public. And then you have protected. So this would be like rooms which only family members or relatives have access to, right? Even guests cannot enter these protected spaces, right? So far so good. So these are access modifiers. So far so good. Okay. So in classes, we also have um, so when we're looking at methods, right? Remember I said there are private variables, right? Even though let's say your program needs these variables to work, right? It needs these variables to be manipulated, but we don't just want anybody to manipulate them anyhow. Okay, I'll answer your question now, or I'll give you the opportunity to speak now. We don't just want to give access to anybody anyhow, right? So this is when we create some functions called accessor and mutator functions. So these functions are like the ATMs of the bank. So if you think of that bank analogy, they're like the ATMs, or like they are the tellers, right? Who you go to them and then you tell them you want this, you wanna take out money, then they go fetch the money and they give you the money. Or you tell them you wanna deposit money and then they take that money and then they go put it, because they know how to do the balancing of the books and whatnot, right? So these are like your accessors and your mutator methods, right? You don't get direct access to the variables, but there are some functions which work with that, right? Um, Ramudzuli, you had a question?
Uh, uh, is there a limitation on derived classes or a uh, probably let's say uh, this class is derived from another derived class, or a, its status on accessing from the base class?
Okay, can you repeat your question again?
Say you have like a derived class, which is like derived from another derived class.
Okay. So like a grandchild.
Yeah, something like that.
Okay.
So can it access the same thing from
Base
the
class.
the base class?
So yes, as long as it's derived and as long as those members are either public or protected, then they can be accessed by the derived class.
So what about private?
Private, even the first derived cannot access those ones. So it
Oh,
only,
okay.
yeah. Good. Any other question before I move? Okay. Now in computer science, obviously, even though a lot of us, me included sometimes, you don't like doing this, but you have to design whatever you want to build before you build it, right? And then this usually helps you a lot in when you are coding. You don't spend a lot of time coding and troubleshooting, right? So whenever we are designing classes, we are going to use the UML notation, or we are going to use UML. I forgot what UML stands for. Does anyone know what UML stands for? UML, Unified Modeling Language. Okay, so it's just it's like graphic design, but much more technical, right? So remember I said there is public members, there's private members, and there's protected members. This is how we represent those in our UML, and you'll see this also applies sometimes in code as well. Well, in no, so yeah, in code you write the words, but then in the UML, this is how you would portray. So if you want to show that a variable is public, you put a plus next to the variable. If it's private, you put a minus. If it's protected, you put a hash, right? UML is like a flow chart for your class. It shows who can enter which room. So let me show. So it's yeah, basically the design, right, of your class before you build it. So this is an example of the types of UMLs you'll be designing, and this is a very simple UML. Um, you can see, so we're gonna have different little arrows here. This one is for composition, I believe, yes. So this is an example of a UML, and then this is a emoticon or an emoji or a picture, and then these two classes are classes which are gonna draw on this picture. So if you wanna edit the emoji or the image, you're gonna use these classes to do that. And then if you can see on our class, we have these private data members, right? You see they are private. So these, they are only accessible within this class, right? So when you're coding your class, you can only directly access them in that class, right? So if you are coding maybe this function here called draw, you cannot directly access rows and columns because they are private, right? And then you have int rows and int columns. These are public, and then they are underlined because they are, let me open this, then we'll see. So that was int rows and int columns, right? Should be here somewhere. um so they are public. Where are they now? Oh yeah, here they are. So they are constant and they are static. So they are constant in the sense that they never change. So these we use this because they are like sort of our default values, right? So we'll see when we go to constructors and destructors why we would have something like that. So here are the functions. So these were the data types. So it's, as you can see, it is Okay. It is divided. I'll get to you now. It's divided into three sections, right? The first section you just have the name of the class. The second section only contains the data members or the variables. So this can be your arrays, your integer strings, structures, and things that hold data. And then the third section would include all your functions. Right, so here you can see we have the constructors. So whenever you're creating an instance of that class, these are the functions that can help you do that. So this one is a default constructor. You see it doesn't take, okay, it doesn't take any parameters. So it's gonna use some default values. That's why we had those default integers in there. And then we have this one, which is defined by us. Oh, we define all of them, but then this one, the user or the client has a say in how they want their class to be created. So if you think of that analogy of the house, let's say we have this blueprint and then someone just says, create me a house. We'll just create it with maybe like basic colors. We just say the house is white and the tiles are whatever, just the basic things. But then there's also an option for the client or the user to specify the color of the walls, what type of grass they want, um, and so forth and so forth, right? Yes, before I continue, let me allow you to ask your question.
Can you go back on the last slide?
Yes. This one.
No.
This one.
No. Okay, just go back to the 7-1. Okay. On the constructor thing, there's a close brackets. What
Yes.
does it mean? Yeah,
Okay,
close
so
brackets.
this is like a when we use you're gonna use dia. Um, this is just to specify that like it's sort of like a subheading. It doesn't mean anything really. It's this is not a function. It's just a heading that these are the constructors, and you can see there's another heading saying these are the exercise methods. And then I forgot to put another heading here, but there's also a helper method. So functions that help do stuff, those are usually private. Um, yeah, so it's just like a heading. It's not a function or, but you just need to have it there. Usually these arrows, when you put them in the heading, it means that the class is an interface, which we will get to a bit later. But for now, they just mean that it's a heading. So you see, I have grouped my functions in some order. So at the top here, we have your constructors and also your destructor, which is specified by this little curly thingy here. So this is the destructor, and then these are the constructors. So we have one, two, three. So this is the default constructor, the constructor with parameters, and then this one is a copy constructor. So if you want to make a copy of an instance, you would use this constructor and give that instance as the parameter, and then it will make a copy. Um, these are exercise methods. So these are those methods where it's like the teller, right? You can see here it's get row, get column. These are access, they help you access these private variables, right? Set color. So think of that bank. Get row will probably be like a withdrawal, and then set color would be like a deposit, right? So you can even make a banking app using you can make a banking app using classes, right? So imagine this is your bank, and then you have here account, maybe name of account holder, and so forth and so forth, and you have some accessor methods. So they are called accessor and mutator, right? So accessor methods are the ones that give you access. So they give you things, they give you access, right? So like your get row, your get column. Uh, just excuse me one moment, guys. I'm so sorry. But yeah, so we have accessor and mutator methods, right? So the accessor methods, they give you access to the data, right? And then the mutator, they mutate the data, so they change the data. So usually those will have set in front of them. But yeah, these are just naming conventions. So you can get stuff, you can set stuff, you can draw. So drawing is basically, um, let's see here, drawing would be editing this thing, right? So in a sense, it's also a mutator because it's mutating our emoji, which is also another 2D array. You'll see now when we, or on Monday when we are doing the practical. Draw emoji to ppm, so this just converts our 2D array into a format that can be read by this app that's called GIMP that we're going to be using to view the images. So we're going to draw some pictures and view the pictures. What happened there? Okay. And then we also have allocation. So this is like the normal allocation and deallocation. Cloning is like making a copy. And then yeah, so those are usually the functions you're gonna have inside your class, and this is how it would look in UML form, right? So this will probably be your design for the practicals. You have to create a UML similar to this, depending on the scenario. Any questions so far on the UML? Okay, I'll go to the next slide. So I think someone asked me, I don't know if they're here. I don't remember who it was, but someone asked me what is encapsulation, I think on Wednesday, right? So in our classes are basically helping us with encapsulation and abstraction. So these are two different concepts, but they are very similar, right? So encapsulation, you can think of it as bundling data and methods, so our variables and our functions together inside a class, and restricting outside access to only some components of it, right? And then this focuses on protecting our data, right? If you can think of the bank scenario, you have your bank, it has money, and then it has ways of handling the money, right? So we have a bank so that it can help like restrict people from just like using money anyhow, or like using other people's money anyhow, if that makes sense, right? So we have this construct or this class that stores data and variables, and then you can only have sort of an interface which you have access to, which is going to give you just will give you some parts, will it won't give you everything, right? So if we think of technically like what we've been doing, when you create a class, right? Let's say you're creating a class for some end user. So now I'm talking about a person. That person doesn't really care how you are allocating memory or how you are deallocating memory. They just want to see whatever your app is doing. They don't care about all the other stuff, right? That's where abstraction comes in, right? Abstraction is hiding the internal implementation details and exposing only the functionality for, and it focuses on simplicity and usability, right? So this all happens in your class. Your class has methods and data, and then you only give some things which you deem fit as the programmer. You make them public or private, and then abstraction is hiding like how you are coding, hiding those functions, those details, and then only giving functionality which like sort of hides how you are doing stuff, right? That makes sense. Or should we move to an analogy? Uh, if we think of it like in the sense of a car, right? Encapsulation is the entire, like if you think of a car, right? It has an engine, and the engine is like in the under the hood or under the bonnet if you're from South Africa, or if you're from Africa, right? We call it a bonnet. You're not allowed to access like you don't really have access to the engine when you're driving. You have access to it indirectly, but you're not the one who's putting in the fuel and the air and doing the spark and doing the combustion. It's not you who's doing that. You are just controlling like the pedals and stuff. So encapsulation is hiding all of that stuff, right, inside the hood, right? And then abstraction is now is how you are only shown the steering wheel, the gear shifter, and the pedals, right? Those are the things you interact with. You don't interact with the inner workings of the car. So you are able to drive the car without needing to know what the engine is doing, right? You are able. What have you been coding? What have you been coding? You are able to do the simulation, right, without having to know what the simulation is doing, right? You can use it, but you don't know how it really works, right? So you use the car without knowing what's under the hood. That's abstraction. So you are just driving with the steering wheel and the pedals, but you don't like know what's happening in the engine, right? And that makes it enjoyable because imagine every time you're driving, you have to know how much fuel to put in each cylinder and all those complicated engineering stuff. And then encapsulation is you can't tamper with the engine's internals, right? So you are hiding, so the engine is hidden away from you, right? So that is encapsulation and abstraction. Encapsulation is us hiding the data and those functionalities, and abstraction is us giving the user or the client access to only use our product and not know how it really works, right? Uh, does that make sense? So this is how it will be, right? If you're using abstraction, you're just sitting in front there, everything is fine, you're just driving. But without abstraction, you'd have to control the engine yourself. Like every little thing that the engine does, you have to do that yourself, right? Does that make sense to everyone? Abstraction versus encapsulation. So encapsulation is us hiding the data. Abstraction is only giving the person access to how to use it and not telling them how the things are actually happening, right? Any questions so far? Any questions so far?
Uh, how do we apply abstraction?
Okay, so let me show you an example. How would you apply abstraction? So what our classes are going to do is basically abstraction, right? We're going to abstract what the class is doing, and then we're just going to give the client. So remember, the client can be main, or it can be the end user, or it can be even another class that is using your class. You'll see you see how, okay, I'm going off track, but you see how these classes are sort of connected, right? This class, this is its own class, and it has it is connected to this class, right? This class draws circles, right? So what I'm trying to say is the functions in this class can be used by other classes as well, right? So your client could be other classes, or could be main, or could be end users, right? So how could we apply abstraction, right? Um, so for example, this is abstraction. Um, let me think. Let me get an example. So in main, right? Yeah, we've actually been doing abstraction in main. So this is like our the last practical, right? In main here we made. Oh yeah, here it is. So this function initializes the game state, right? If I am the programmer or the person using you created your simulation module, right? And you gave it to me, and then I want to create a simulation, right? I know that I have to create the state, or I have to initialize the system, I guess. I only know that I need to call this function, give it rows, give it columns, give it how many times I want the simulation to run, and give it how many particles are in my simulation. The person calling this command doesn't know that we have to create a 2D array, and we have to allocate memory, and we have to find a random number, and we have to check if it's in bounds. All those details, or all these functions here, You can even think of it, all of these functions that are not exported, right? Like the allocation. I don't know how to do the allocation. I don't know how to place features. I don't know how to, what else is here? I don't know how to check if it's in bounds, but I am just initializing the world. So you see a lot of things come with initializing the world, which your client does not need to know because it does not benefit them. They just, let's say they are scientists, right? They just want to see their simulation run. They don't care what you're doing behind the scenes, right? So that is an example of abstraction. They just call this function, right? That answer your question.
Yeah, sure.
Okay. And then, yeah, this way we go. Now we want to move to now using the modules, right? Because this was going to be done using the .h and the .cp, the header file and the implementation file. But now since we are using the module, it's going to be a bit different, but it won't change a lot, just that everything is going to be in one file, right? So information hiding is the principle of only exposing what's necessary, right? So like I was saying, you only give the client functions that they need to use, right? The client does not need to know how to allocate memory or how to deallocate it. They just need to do whatever your program is doing, right? So if it's maybe running a simulation, they just need that function run simulation, right? They don't need anything else. So only exposing what's necessary, which is the interface. So the interface, think of it as like your phone, right? You have a screen which you interact with. You don't really know what the battery is doing, how the memory is being allocated through across the apps. You just have your screen which you're working with. So you just have access to the interface, but then the internal workings of the phone or the internal workings of your program are hidden, right? So that is what information hiding is essentially. We're just hiding everything in the background and only exposing what is necessary. So now since we're using modules in C++20, this is done using modules. So we don't have the header file and the implementation file anymore, which sort of used to do that for us because we have the header file, which main had access to the header file, right? And then it will call functions there, or public functions, and then the implementation was hidden away, right? So you can do this in multiple ways, right? So in a module, you can have a interface section and we can have an implementation section. This will make like your code look cleaner and it will sort of resemble this but in one file, and it is safer and faster to compile. The user, oh, what is happening with my slides? Okay, so we'll see that now. The user or the client code. So you see how they're saying client code. This is like main, right? Yeah, this is like main. Only sees and uses the public part. So when we are creating a class, there's gonna be public and private and protected, like we said, right? And then they only have access to the public part. They only have access to protected if they are a derived class of that class that they are working on or working with, right? And then the internal logic, like how you allocate memory or validate the color values. This will be an example of the emojis, right? How you see, how you setting the, oh yeah, how you validate color values, like if the color actually exists, is hidden inside the module. Um, or it will be hidden inside the export part. No, rather the part that's not exported. And then using the same car analogy, you, the driver, this is like the client, right? You interact with the public interface, the steering wheel, the pedals. That's the functions which you have access to, or the public functions, right? You don't see or have access to the engine, the transmission, or brakes. Those are hidden behind like the dashboard and behind all of your interior, right? So modules are the dashboard. They help you expose just enough for driving but protect all the machinery under the hood, right? So imagine if you are creating a program, let's say for some older people, right? So some senior citizens. You don't want to give them complete control of everything because they don't really know what they're doing and they might mess up your program and run into errors and so forth, right? Let me see here. Uh, d- 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 Now this is the old code. If you look at this code, right? So this is gonna be our module, right? Um, Same thing. Don't forget this thing of putting the export under here. So if I just explain this, right? The only difference now is we have a class, right? Um, yeah, we have a class called UJ image or a class called image or a class called emoji or anything like that, right? So in the class, that's where you're gonna create your public, your protected somewhere, and your private members, right? So you can see this is sort of like an implementation file where it's just the definitions and the data, right? Here's the data, the rows, the columns, the arrays, right? So this first part, which is exported, is only it's the interface essentially, right? And then inside the exported class, right? Main still only has access, or the client still only has access to the public stuff, right? So it does not directly have access to the private stuff. Even though we are able to access them through the accessors and mutator methods, we don't have direct access. So we cannot call these variables and functions which are private, right? So after we declare our class, we'll do that now probably on Monday when we're doing the practical because it's almost 9:30. Um, Whatever we want main to have access to, we'll put it inside public, and whatever we want to stay hidden, we'll put it inside private. If you can remember in the last practical we did, how we were separating what is private air quotes or public was we would put export in front of it, and then if it's not like this one, if you want it to stay hidden like this one place feature, we wouldn't put export. So think of this as like private and then here as public, right? But in the case of now classes, we're just gonna export the entire class, but within the class we're gonna have public and private, and public uh, is accessible outside the class, and then private is only accessible within the class, right? So after we do this sort of interface, right, we will now need to define our class, right? So you can see here, this is the definition of the classes, right? So this is like the implementation file, that all your classes you define them right below the class, right? So imagine just turning the .h file and the .cpp file into one file, but with some extra steps and precautions, like putting, uh, yeah, you see here, this was already a mistake, putting import below the include statements. Yeah. Uh, so that is what we will need to look at when we are coding. And then we also have these static data members, like ones I showed you. Now these, I think I remember saying this, but static members are essentially variables that belong to the entire class, right? So if we go back to our plan, uh, if we go back to our plan here, if you have a static member, it will belong to the plan, right? Think of it as belonging to the plan and not an individual object, right? All of these objects are gonna have their own set of variables. So like if these were our let's see, our classes with pictures, right? With rows and columns, right? Each of this will have its own rows and columns. This one rows and columns. This one its own rows and columns. But static members are those or yeah, usually it will be only one, right? Not one as in you can only have one static member, but when you create a static member, there is only one of it that exists. So and it will service all of them, right? So think if we are thinking technically, we can think of it as a counter variable, right? Or let me read this. So a static member belongs to the class, not the instance, right? So it does not belong to an object, but it is class level, right? So all of the objects that you create have access to that static member, and you can allow the objects to change it, or you can just allow them to just view it, right? So these static members are shared across all objects of the class. Here's an analogy. A school rule is the same for all students, and it's like a static member. So there's only one of it for everyone, right? Even though there are many rules, but those many rules, there's only like one set of them, right? You can also think of a counter, right? So let's say you're creating an app and you wanted to keep track of how many objects you're creating, right? You would probably want to have a static member, which is like a counter. So every time a class is created, or an object rather, an object is created, it will be incremented, right? And then let's say we increment a class, or we create a class, the counter will be incremented by one, right? Let's say we create another class, then it will be two now, and so forth. So that is a static member. Think of it as like a global variable for all your objects, right? Does that make sense? Static members and why we might need to have them. Are we good? Are we good? Are we good? Are we good? Okay. And then this one you guys know. So we have passing by value versus passing by reference. Uh, yeah, passing by value, we are creating copies of the object. So whenever you pass anything by value, it can even be a variable, right? You're creating copies of that member or of that variable, right? And this is slow if you have big variables, right? Imagine you have this variable that is like 2 gigs, because remember variables are data, right? So let's say it's 2 gigs big. Okay, yeah, you guys know this. Yeah. Pass by reference, uh you share the original object, right? So you give them the address and then they have access to the object directly. So it's efficient as in you only share an address which is smaller, but it's risky in the sense that someone might alter the original object and maybe you don't want them to alter it, right? So value, passing by value, you're making a photocopy, and passing by reference, you are making you're handing over the original. Yeah. Okay. I think for today, you're not supposed to see that yet, but for today, I think that will be our class in the interest of time. And then on Monday, we will implement all of this in our practical. So